be teaching you about stress, strain, and the elasticity in the human muscles.
So now we're going to give you an overview of the main terms of this topic, so you basically know what's going on when we're teaching you it.
So stress is the term for the forces that act upon the muscles of the body.
And then the strain is the reaction of the muscles to the stress placed upon them. Like, for example, when your muscles contract, that's strain on muscles in reaction to the stress.
Elasticity is the ability of an object to stretch and then return to its original position or form. Muscles must have elasticity in order to allow the body to not harm itself when doing daily activities such as lifting boxes.
So all these come together to allow the muscles in the body to respond to situations in the environment and keep the body safe from injury. So when too much stress is placed on the muscles, it causes them to strain to an extent greater than they can tolerate, and this deforms their elastic quality and can cause injury. This equation is called Young's modulus. It uses a proportionality constant between stress and strain, and it helps determine the elasticity of an object. So stress in its basic definition is the amount of force applied to an object divided by the cross-sectional area that is being applied to. Strain is the change in the length of an object divided by its original length. These two separate ratios can be combined to demonstrate Young's modulus.
Young's modulus can be rearranged to more clearly depict how, as the amount of stress increases, the strain on an object also has to increase as E remains constant. As stated before, stress equals the force on an object divided by the cross-sectional area it's applied to. If the force on an object is spread over a larger area, then the stress on an object will not be as great. Or when the force on an object is over a smaller cross-sectional area, there is more stress upon the object. As seen in the rewritten equation, the change in length of an object is directly proportional to the force applied to that object. If the force upon a muscle is increased, it will cause a greater change in length. This relationship demonstrates why as stress on the muscles increases, the responsive strain increases as well.
This is an example problem that represents how Young's modulus works. So Josh is doing bicep curls. If the weight he is lifting is 20 kilograms, the cross-sectional area of his bicep is 7 centimeters squared. His bicep is approximately 13 centimeters in length, and the change in length of bicep is 1 centimeter. What is the constant E? So over here I have written the variables that we were given in the problem, and then we're going to want to convert everything to meters. So this is going to be 0.07 meters, 0.13 meters, 0.01 meters. And so now that everything's like in the correct units, we're able to determine that force is mass times gravity. And since the mass of the weight is 20 kilograms times 9.8 gives us 196. And so then we're going to plug that into the Young's modulus equation here, where force over area all over the change in length over the original length. And so since the force is 196 over the area, which is 0.07, and then we have 0.01, which is the change in length, over 0.13, which is the original length. And so then once we put that into the calculator, it gives us 36400, and so that's what E is.
Okay, so this graph demonstrates the relationship between stress and strain, and it shows the elastic limit of an object. So as you can see, in a brittle object, such as like a bone, you have to apply a ton of stress to increase the strain upon the bone, because the strain is the change in length. So as you're increasing stress, the brittle object isn't going to stretch as much, and so you have to increase a lot of stress in order to increase the strain. And so you see like this really great high sloping line. This ductile would be like muscles in the body. So since they have the ability to stretch, as you increase the stress upon muscles, the strain would increase greatly. That's why this is more gradually sloping. And then as you can see, at first, for both different substances, brittle or ductile, it's a linear line, and it's following Hooke's law. And then as stress increases to a certain point, it starts to follow Young's modulus, which is not linear. And then at the end, this would be the breaking point. So like this would be in a brittle substance, this would be like when your bones actually break, when the stress is too great and they actually fracture, and that's the elastic limit. And so in muscles, as your muscles stretching and stretching and stretching, once they reach their elastic limit, they're actually going to tear. So that's why like here would be when you're starting to strain your muscles and actually harm them, but once they actually hit the like complete elastic limit, you can actually tear a muscle. So like this is really important to know in like the medical world and such. So this graph just shows you elastic limit.
So I'm going to demonstrate the difference in stress and strain in different materials. So in a rigid material, when a large stress is applied, there will not be much strain because since strain is the change of length, and if there's no change of length, then there's not much strain. So there's just a large amount of stress applied. But in an elastic material, when the same amount of stress is applied, there's a larger change in length, which means the strain is increased. So in materials such as muscles, they're easier to strain because of the change in length is so large. So with different weights, they cause like different amounts of strain because when you're moving the weight, as it's like for this one, it's a 5-pound weight. So that way, whenever it's being lifted, the length of the muscle is being stretched by gravity is smaller than when you're using like a 10-pound weight because the force is higher, causing a higher amount of stress, which is causing more strain, which is why it's important to not use too heavy of a weight when working out.
Okay, so as Paige is working out, she has to make sure to use the 5-pound weight first, and then as her muscles are strengthened due to using weights, she can now tolerate the larger weight because as you work out, your muscles grow, and so now there's a larger cross-sectional area, and that means you can apply more force to your muscles, and so that's why when you're working out, you start with lower weights and you work your way up to higher weights because you're increasing the amount of force that your muscles can tolerate so you don't reach the elastic limit of your muscles and destroy your life.
When the force of stress is too great for the human muscle to bear, it becomes extensively strained. This is called exhaustion because the muscle becomes too exhausted to function properly. When the muscle is too strained, it becomes very tense and cannot relax back to its natural state. In this tensed up state, it slows blood flow by impeding on capillaries and crushing the veins that the blood flows through, slowing the blood flow throughout the body. So this inhibits oxygen from reaching the muscles and keeping them strong, allowing them to regenerate. And so with this lack of oxygen, the muscles can't regenerate and build upon themselves and heal. So they begin to break down and degenerate, and this leads them to be very weak and unable to function properly. And also with this slowed blood flow, the correct nutrients can't reach the muscles either. So this causes the body to start breaking down itself, and without the function of the muscles, the body becomes exhausted too. This state of the muscles is called disease because the body is turning against itself and breaking itself down instead of building itself back up.
So it's obviously important for athletes and physical therapists and doctors to understand how forces affect muscles in order to make sure that they're not harmed and they can keep their muscles safe from injuries. But it's also important for everybody in all aspects of life because whenever you lift something, walk up the stairs, you're causing strain on your muscles due to the forces of stress on your muscles. And especially since we're all going to college next year, we're going to be moving into dorms and stuff, every time you lift something, you're causing stress and strain on your muscles. And so it's important to understand this in order to not hurt yourself and so you can have a fun time at college. Because that's what we're all really here for, to get through high school so you can go to college. So hopefully you learned a lot about stress and strain, and we hope you enjoyed our video.